A little bit about me. I've been a software developer since 1995. I work for a company called NIS Technologies, where I'm a senior software engineer, and I've been certified with a few certifications from Microsoft. I also run the Cleveland C# VB.NET user group, which meets online. And although we're based in Cleveland, naturally, all the meetings have been taking place online due to COVID, so it's accessible to everyone from anywhere. I've also run the .NET study group, which also meets online as well. And I've authored several articles for Visual Studio Magazine, and I've been a 5-time Microsoft MVP. So getting into temporal tables, what are they? Basically, they are system version tables where whenever you have a table in SQL Server, you can make it so that there's a system version table that goes along with it, or a temporal table that maintains a backup copy of the data. It's based on an ISO standard, and it's a new feature in SQL Server, so it doesn't support all the temporal table features that you may find in other databases such as Oracle. But it maintains current and past states of modified rows, and it's a standard feature of all editions of SQL Server starting from 2016 and later. And you can implement this via T-SQL, so there's no additional configuration needed. As far as the requirements, what you need are basically a couple statements inside of your T-SQL. So looking at what we have on the screen, the requirements for setting up a temporal table is that, first of all, you need a primary key, and you need to specify 2 period columns. That is the start column and the end column. They are of the date time 2 type, and you can name them anything, but they have to be non-nullable. And when you're specifying the column names for the temporal tables, you specify the column for the start column and the end column, and you will specify the clause generated always as row start or generated always as row end, which means that essentially that these date times are auto-generated by the system. And we specify the designation period for system time, and then we specify those 2 columns within that clause. Then, in addition, we also specify with system versioning turned on to turn on those features. And then we can also identify what the historical table is going to be. So essentially, think of, for every table that you have in the database, you can set up a temporal table that will have a backup copy of that data, a historical backup. So anytime you make changes, those changes are stored in the historical table, but yet the current table contains the latest and greatest updates. And so again, looking at the bottom portion of the screen, where you see create table department, we specify the key features that are needed for creating a temporal table. So as mentioned above in the numbered list, we have a department ID, which is our primary key. And because it's a primary key, we set it to not null and as an identity field. And then we have the valid from and valid to. Those are specified as date time 2 types, with generated always as row start and as row end. And then you see that we specify those 2 columns in the following line, period for system time, where we specify the valid from and the valid to dates. And then continuing on to the last line, you see that we specify with system versioning equals on, and then we specify the name of the history table. Okay, so once we have that set up within our T-SQL, then we have a database that we're actually using, and going forward, we can now query the temporal table. And to do that, we just simply specify within our select clause that we want to specify a specific time period. So the first 2 lines are very basic select T-SQL, select star from department. But now that we have a temporal table, we're specifying that we want to look at the system time when those records were valid. And so we're specifying for system time as of date, and here we're looking at the system date time, and we're subtracting 30 days from it. So basically, it's retrieving everything from the department table, all the rows, going back to 30 days. So if a user deleted a record, let's say 10 days ago, it will also appear within the query as well as any updates that have happened to that row. And then we can end that statement by, excuse me, ordering by the employee ID. So as you see, it's a pretty standard SQL statement with exception of the for system time clause. So what are some usage scenarios? Where can temporal tables be applied? Basically, it allows us for querying a table at a specific point in time. So we can actually travel back to the 30th day and we can take a look at records then, or we can retrieve records that have been updated within the last 30-day period. And we'll talk about that in just a little bit using the T-SQL clauses. And so this would be used for slowly changing dimensions of a data warehouse or an active database. And it's used for auditing when the change was made. Now, notice that the key word here is when the change was made, as opposed to who made the change. For who made the change, you'd want to utilize something like CDC, change data capture, which we're not going to be discussing in much detail here. And it can also be used for recovering from accidental loss of data. Because I have the temporal table on my active table, I can now, if I was to accidentally delete a row from my active table, I can go back into my temporal table and be able to retrieve a record in its last state before it was deleted. It can also be used for anomaly detection, where things that don't make sense, meaning values have changed in a variety of ways and have been altered. I can look and see the trend of those values and how they've changed. For example, if someone changes their email often, I can look and see how often they've changed their email, and it maintains a historical record of that. And it can also be used for repairing row-level data corruption. So if a specific row has been corrupted, I can go back into my temporal table and retrieve the previous version of it before it was corrupted. So for enabling temporal tables, basically what this involves is that I can set temporal tables for existing tables, or I can use them on new tables. And I do that again through T-SQL. So if I have an existing table, then in order for me to enable a temporal table on that existing table, I have to utilize the alter table statements. And then I would set the default values that initialize the period columns with zeros. So if you look at the example in the bubble below, alter table, where I'm going to alter the table employee, and I'm going to add the start date and the end date. And if you recall, those require that I have a generated always as row start and generated always as row end. So every temporal table has a start date and an end date. I can name them whatever I want, but I have to specify that they're date time to type and the clause generated always as row start, as well as not null. So this was all specified in a previous slide. And then in addition, once I configure my temporal table, then I have to specify that the system versioning is going to be turned on, where now SQL Server Engine will automatically back up the data every time it's changed and stored in the temporal table. Any questions so far? Again, feel free to either type it in chat or ask verbally. Okay, if there's no questions, we'll move on. So once I'm querying my tables, basically I need to utilize these clauses. Like I said, I can go back to a specific point in time on the 30th day from today, or 30 days ago exactly, and see what the data looked like back then. Let's say a scenario where I have a customer who changes their email often, and they're complaining that they're not getting the email for the confirmation on the product that they ordered. So I can go back on the day that they ordered it and see exactly what their email was set to in their profile. So I can go back to the 30th day, to a specific point in time, or I can say, give me all the rows starting from today, going back to 30 days and everything that had changed in between. And I can use that, I can do that using the clauses that are shown here, the subclauses. So I can specify as of a specific point in time, or from a specific point in time to another point in time. And notice there, I have from start to end. And the next one, between start and end, it's identical to the one above it, except the only difference is we include that the sys start is less than or equal to the end date, as opposed to sys start is less than the end date here. So the equal sign is what's key here. And again, I can specify what's contained within versus the date between or from a specific starting point, or as of a specific date. Okay, I know this may seem a little confusing, so the best way to do this is to demonstrate it, and we'll go through a demo. And allow me to share my screen. So sharing my desktop, there you see the T-SQL script that is used for creating it. And as listed above, this is valid for SQL Server 2016 or later. So what I have is a sample database that I'll be creating, and I'll call it Temporal Demo DB. And we'll check to see that it doesn't exist. So we're starting off with a clean slate. And then I'm going to go ahead and create my Temporal Demo DB. And we're off to a little problem. No problem. Okay, so we can do this. Temporal Demo DB, we get DB1, 2, 3. Let's call it DBX. And so that took a minute to create. We got Temporal Demo DBX, and we want to change to that database. Okay, now what I'm going to do is I'm going to create a couple tables, territory managers and customers. So territory managers is very basic, right? We have our primary key. We have a couple fields for first name, last name, and territory name. And we'll go ahead and create that table. And now I'm going to create a customers table. So customers table, I want this to be a system version table. So anytime there is a change to any of the records in the customers table, I want it to be reflected and stored in a historical table. So just like all other tables, I specify the name of the fields, the data type, whether it's null or not null. And so I have a variety of different fields here. The key one is my primary key. In addition, in order for it to make this a system generated table, I have to specify a sys start time and a sys end time. It has to be of datetime2 type. And I have to specify the clause generated always as row start and generated always as row end. Easy enough. In addition, I'm going to take these two column names that I specified here in my creation, and I'm going to say period for sys time, and I'm going to include those two column names.
Sorry.
So as I was discussing before, that little technical glitch, that we already created a territory managers table, and now I'm going to create my customers table, and I'm going to make my customers table a historical or a system version table. And so again, to do that, I need the primary key. I need to specify sys start and sys end, and I need to include those column names after I define them in my period for systtime clause. In addition, what I'm going to do is I'm going to turn system versioning on, and I'm going to specify that I want my historical table to be called customers historical table. Notice that I am only specifying the structure for my customers table up here. And I'm saying that I want the default name of the historical table to be just called customers historical table. So let me go ahead and execute this portion. And that executed. Now let's take a look at my Object Explorer. I'm going to refresh my database. And we should see my temporal demo dbx, which is right here. And then underneath it, when I expand my tables, and it's taking just a second to expand, we see that I have system tables, file tables, and then all my user created tables here. And let me go ahead and zoom in for that. And so for my customers table, you see that it says system version next to it. In addition, you'll see that the icon for that table is a little bit different than my standard territory managers table. You see that there's a clock next to it with a calendar. When I expand my customers table, you'll see that immediately underneath it, I have a customers historical table. And I don't know why the expansion is not cooperating here. But under the customers historical table, when I expand it, I see that it has all the column names that I specified in my customers table. So there are the columns for the historical table, and you see that it is an exact replica, or almost an exact replica of in the historical table versus the current table. The only difference is, looking at this primary key, it's called ID, and it's set to a PK or primary key. But if you look at it in the historical table, it's just a plain old integer field, not as a primary key. The reason for that is because this historical table acts as a data warehouse. So I could have multiple changes to a specific record, and so that needs to be reflected in the historical table. And I will better explain that through the demo as we proceed. So any questions so far on creating a historical table? Okay, so moving on, we have the customers table as well as territory managers. Now what I want to do is affiliate the territory managers with the customers using the foreign key. So I've already turned system versioning on. I'm going to go ahead and alter the customers table and add in a foreign key constraint. And now what I'm going to do is I'm going to insert some territory managers. So this is just a plain old insert statement. And now what I want to do is I want to affiliate customers with the territory managers that I have created up above. So I'm going to specify some of those customers, and I'll insert them in. And you'll notice that I have the territory manager ID relating to the territory managers specified in the previous step. So we'll go ahead and execute that. And 3 rows have been inserted. And just to give you an idea of what the tables look like, we have 3 territory managers. We have 3 customers. That includes first name, last name, address, and email. So that's my customers table. What does my historical table look like? I can just do a simple select statement on it, and currently it's empty. That is because there have been no changes made to the current table. Now let's go ahead and change that. So for the first demo, what I'm going to do is I'm going to change a specific user's email, and let's take a look at that user. So again, we're going to select from customers. We have Tina. So this customer, her email is going to be changed quite often. And what I'm going to do is I'm going to execute the script. Basically, what I'm going to do is now I'm going to update Tina's email to be yahoo.com. So we're starting off with outlook.com. We're going to change it to a yahoo.com address. Okay. Now we're going to wait a couple seconds, and we're going to change it again to a Hotmail address. And then wait a few more seconds. And we're now going to change it to a mailx.com address. Okay. So let's go ahead and change that. Now, when we query the current table, we only see just 3 records, and I have the latest email address for the user that I'm specifying. So tina1@mailx.com. However, when I query my historical table, you'll see that I have 3 records for the same ID with 3 different emails. And more specifically, looking at the sys start time and the sys end time, it shows me when this record came into existence and when it ended its life, so to speak. So I have the sys start time. It started at May 11th, 13:56 and 48 seconds, and it ended at 13:58:01. So approximately 2 seconds later, that record is no longer valid. In addition, I also changed it to a Yahoo address, which started at 13:58:01, ended at 13:58:10. So you see that it shows when that record was alive, so to speak, for lack of a better word, when it was valid. I have a sys start time and a sys end time. Going back to the customers table, whoops. Looking at the customers table, I only see the current record. But then if I scroll to the far right, I have the sys start time and the sys end time. So you'll notice the sys start time for the first and third record, they're identical. That's because I only made changes to this middle record here. And I made multiple changes to it. But the last change was made at 13:58 and 41 seconds. If you look at the sys end time, you'll see that it shows the year 999, 9, I left out a fourth 9, December 31st. That is essentially the equivalent of infinity in SQL Server. December 31st at midnight in the year 9999. So what that's telling me is this record essentially came to being starting at 13:56, and because the sys end time is infinity, it continues to be valid up until I have a different end time. In the current table, I will never have a specified end time because it shows me just the current records. The historical table is what maintains a history, and it shows me, and let me query that, and it shows me when that record came into existence and when it was no longer valid. So it has a valid end time as opposed to infinity. Make sense? All right, so we talked about the customers table and the historical table. Now I want to query it for a specific point in time. So let me go back and grab a date here. So there's a question in chat regarding, is there any possibility to integrate temporal tables with graph data objects, edge or no edge? That's a great question. Honestly, I don't know. I'd have to look into it. But if you drop me an email, I can follow up with you on that. And my email, again, I will post that here. snasr@nistechnologies.com. Another question, what about big size types, varchar max, var binary? The entire row is copied to the historical table. Even if you not change the values in these columns, this can consume a lot of disk space. If the data are changed often, that is correct. It all depends. So one of the questions I always get is performance impact. And that just depends because essentially, like you said, you're duplicating the entire table, whether or not it has changed or not. So well, let me rephrase it. You're duplicating the entire row with and without changes. So if you change only one field, let's say it's an integer field or a byte field, it's going to copy the entire row, including any varchar maxes, any binary fields. All that's going to be duplicated. So a perfect example, again, I forgot that my screen's frozen, but as we had seen, we see that the email for the user that was changed was reflected, as well as all the other fields that have not been changed have been reflected in the temporal table. So that could be a performance impact. Again, just depends on your situation and what the table size is. And then, is it possible to exclude these columns from history? No, unfortunately, the table structure has to be identical with it, and then you have to specify the sys start and sys end time, and it has to be duplicated in both. So regarding the design constraints, again, because we said we're now duplicating all the fields, there are some things that it is currently not capable of. And one of them is the file stream. So if you recall the file stream data type, that allows me to be able to identify a file within the file groups and be able to store a pointer to it in the table. And so essentially, if I was to make any changes to that file, I would have to duplicate that entire file as a whole. So currently, it is not supported within SQL Server for historical purposes. Second, the history table cannot be modified directly. You can only add to it by updating or deleting records from the current table. So when we have system versioning turned on, we can't modify the historical table. And it makes sense because if we were able to do that, then we lose data integrity. Instead of triggers are not supported, and after triggers are only allowed on the current table. Indexing must be manually enabled, and you cannot change the schema of a temporal table without changing the current table schema. So what happens is you had seen the system versioning turned on, and then we can turn it off as well, meaning we don't want to maintain history. And then if it's turned back on again, what it does is it compares the schema for the current table and the historical table, ensures that everything is identical, and then it allows you to continue to run system versioning. Changes to the current table will be reflected on the temporal table automatically, as we had seen. So anytime we modify the current table, it will be reflected on the temporal table as well. So as I mentioned, with the system versioning turned on, whenever we execute that statement, essentially these 10 steps are executed. It checks to see that the name and the number of columns in both the current table and the historical table are identical. It also checks that the data types match, and it's looking for the period columns, and more specifically, it's ensuring that the period columns are not null. So anytime we make a change, there has to be a date time specified for those period columns. The current table has a primary key constraint, and the history table does not have a primary key constraint. And as we had mentioned, because the historical table acts as a data warehouse, we cannot have a primary key on it because we're copying that primary key from the current table. No identity columns are defined in the history table, and identity columns are basically auto-incremented, and so we can't have that. We're basically copying everything from the current table. No foreign keys are defined in the history table. No table or column constraints are defined on the history table. However, you can have default column values on the history table. So those are permitted. And the history table is not placed in a read-only file group. So when I set up my database and I have a read-only file group, I can't have the historical table in there because then I won't be able to modify it, or the engine won't be able to modify it. And the history table is configured for change tracking or change data capture. Excuse me, not configured for CDC. So I'm going to pass on the demo at this point because of the problems we've been having, but I want to continue on with a couple slides. So with the security principles, basically for enabling and disabling, there are some security permissions that I can identify. I can allow my users to be able to see the system version table, or I can prevent them from access to it. Likewise, for selecting, I can get into granular access and define whether they can query the table or not. So some best practices to consider. For converting an existing table consider using the hidden clause to hide any new period columns, and this will avoid the impact on existing applications. So basically, you want to hide the new rows, especially in a case where you have developers that always do select star from. Once you pop in those two new columns, that might cause problems with current applications. So if you set them to hidden, that'll avoid any issues. You want to pay close attention to the less than or less than equal to, and that specifies, that is more specific for the in between or the from dates. So whenever you're specifying the constraints for the date, you want to be careful of less than or less than equal to, because then it will be including a specific record or excluding it. And ideally, you want to use a separate schema for the history table. You want to have it in a separate area to avoid any accidental deletions or modifications. And so that's essentially about it. So typically, I would do a recap, but it's kind of difficult to do that with a virtual audience, especially with the difficulties we've been having. But essentially for running system version tables, you can use them on existing tables or specify it at the creation of a table. Keep in mind that essentially we maintain a historical record. So anytime we make a change to a record, we're copying that record into a historical table and specifying the sys end and sys start time. And so that allows us to actually go back in time for a specific point and be able to look at what that record was. So in my example earlier with Tina changing her email, I can say what was her email at 10:15, for example, and it would give me only at that record. Or I can specify what was her email between 10 o'clock and 10:30, and it would give me all the records. If any changes had taken place, it would return all those records that have been modified during that period of time. Some resources that are listed here, feel free to check them out. I also posted a link in YouTube, in the chat, to my YouTube channel, and you can feel free to subscribe to that as well. But more importantly, the link that I sent you has the video with an actual demo and the screen not freezing that I presented at another conference. So it's something to fall back on, and this won't be a complete loss. Lenny Lobel did a couple good write-ups, and so you can check those out on the temporal tables. In addition, some additional links that are listed here through InfoQ and MSDN. Lastly, despite the technical issues, if you found this interesting or interested in learning more and having training, I am also a trainer for NIS Technologies, and we do offer this as a course. So if you're interested, I would invite you to check them out. And the link is nistechnologies.com. Also, last but not least, you have my email, snasr@nistechnologies.com. You can find me on Twitter at samnasr. Also, you can check out my blog, samnasr.blogspot.com. And I invite you all to connect with me on LinkedIn and let me know your feedback, what you thought of the presentation, at least the portion when the screen was not freezing. And so with that, I'll pause for any questions before we adjourn. Any questions, either verbally or via chat? All right, I see someone's typing in the chat window, so I'll wait for that. And thank you very much, Christian. I appreciate it. I apologize that things couldn't have went better. It's one of the more interesting and more exciting parts of SQL Server that I love to demo, but what can you do? There's always YouTube, I guess, but thank you for your feedback. All right, thank you all. I appreciate your help or your cooperation, and look forward to seeing you at another conference.